So, who has used crowdsourcing before for anything at all? Okay, a few people. Have you had trouble with people on Mechanical Turk or Crowdflower not doing exactly what you asked them to do? Yes. So it's quite a common problem, and it's not that surprising as well if you consider that these people are getting paid literally pennies for tasks. But it's not the end of the world. There are things we can do to fix that, and that's what I'm going to talk about. There are basically three parts of this talk. I'm going to tell you about the data that we have. So the whole talk is centered on the problem that we specifically had at Rainforest. But I think some of the techniques will be applicable to everything. But to explain the problem, I will tell you a little bit about the data. I will describe the model that we used to solve the problem, and finally, some practical things about how to deploy something that you created. So, the data. To explain it, I have to tell you a little bit about what Rainforest does, but I'll keep it short. We provide QA as a service, so if you can do functional testing by writing plain English. So if you're booking.com, for example, you would write something like, I want the user to go to the homepage, type in this URL, press enter, log in with these details, and are you on your profile page? And then a tester comes along, they would read this description, follow the instructions, say yes or no, and this way they can find bugs. Because we deal with humans, we need to verify their work, and we use machine learning and lots of sort of manual work for that. So I already told you what the customers do and what the testers do. They come to our website or go to Mechanical Turk and get the task, and then they are shown the instructions that they're supposed to follow and a terminal in which they see a virtual machine with the right browser and everything set up for them to follow the test. And the problems are that some testers, actually most of them are really good, but there's, of course, a minority of people who always just try to click yes, 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 everything is okay, just pay me money and don't waste my time. So we have to deal with that. And the way we deal with that is by having this thing that predicts whether the tester's input represents an honest job or not. It's also a trained machine learning model that does the prediction based on hand-labeled data. And another perspective of looking at this thing is a microservice that exposes the model through an API. And this is just one solution of one way of dealing with this problem. It's honestly probably not the best one, and we do other things as well. So for example, the first thing you should do is to make sure that your testers are trained well, that you explain everything that they're supposed to do and what you expect of them, so that when they want to do good work, they are able to, they know what to do. It's also our responsibility to make sure that their incentives are set up correctly. We can try to build up some reputation. So, for example, we could give testers some work that we know the answer to, and then measure their responses, and the ones that always answer correctly could get better reputation, and then we could trust them more. We can ask multiple people to do the same thing, and then look for consensus. And finally, we can try to detect bad work from input patterns. And this idea is based on the paper from 2011. And we do a little bit of everything from this, but I'm going to talk about the last point. So how do we capture the data? As I mentioned, everything happens in the virtual machine. Everything the testers do is recorded. So their mouse movements, the keystrokes, the network traffic between the browser and the client server, and so on. And it looks something like that. So this is a screenshot of what our testers see without the markings, because we also test Rainforest using Rainforest. We also have a web interface, so we want to make sure it works well. And here you can see that the tester clicked in several places. The circles are where the clicks occurred and where they moved the mouse. We also have information about what they typed and the requests between the servers and so on. So knowing that, what kind of features could you think of? Feel free to shout out anything you can think of. Speed, yeah? That's a good one? Anything else? OK, so we have things like, from mouse, we can get number of clicks, number of discrete mouse moves, the speed, the acceleration, standard deviation of positions, both on clicks and moves, and all these kind of things. And it's always fun to dream up new features that are based on this sort of primitive data, but that represents something. And there are various combinations. The only kind of interesting thing about it, I guess, is how to exactly measure speed and acceleration. You could take the average, but over like a few minutes, that's not really meaningful, so we ended up with histograms. So just empirically figured out what the ranges are, and then arbitrarily bin the speed of mouse moves into several bins. And by the way, scikit-learn is really cool, as everyone probably already knows, because you can get feature importance really easily, and then you can throw away the features that are not informative and keep the ones that are informative and kind of iterate on that. OK, so now we have our recorded data. We know what features we can compute from it, but we still want to really do supervised learning. So we need to label data. And that's a major pain. So some of the developers at Rainforest are not completely happy about it, but what they have to do every day, or now every week, is go through an email they get, click on links, and label data for me. And this way, we manage to get enough information to build up a data set. Now that we have enough of it, we don't have to do it every day, and it's kind of chugging along, and it's working pretty well. The question there is, how do you select the data to be labeled? Because we have, I don't know, something like 5,000 testers online per day. They do, I don't know, tens of thousands of tests, and obviously we cannot label all of it. So which ones do we select to be labeled? We started with just completely random selection. There are probably better approaches, but that's what we did. And then once we had an MVP, something that we felt gave us good enough performance, we started doing this 50-50 split. So 50% of the things that got labeled every day were still completely random, but in the second part, the second 50% was taken from the jobs that the algorithm thought were the worst. So we cared about catching the worst offenders and labeling the data to make sure we can learn how to recognize it. And there are probably better strategies. So if you have any ideas, I'm really happy to discuss this. OK, another problem with that is that our data set is not balanced. Depending on the algorithm, this is not always a problem. But we decided to do explicit balancing before we did learning. And of course, there are different strategies. In our case, most of the work is good, and only a small fraction is fraudulent. So if you use, for example, something like a random forest with no explicit balancing, it will just learn to label everything as good work. So the easiest thing to do when you're and by the way, there are other algorithms that don't suffer from this. Boosting is probably a nice approach. I'm yet to try that, but so far we stick with that. So just to introduce naive sampling, I mean, it's pretty obvious. If you have lots of blue points and lots of orange points and you want to balance, you can just get rid of some of your blue points. The nice thing about it is that it's really simple conceptually, but the bad thing is that you lose a lot of your labeled data. You just don't use it. And that's a shame, considering how much effort it takes to get labeled data. And the way you do it, you just subsample, then you split your data set into train and test, and then you train and evaluate. And actually, in this case, the order is not that important. Another way, sort of the opposite of that, is super sampling. So instead of getting rid of the blue points, you can just create new orange points. The most naive way is just duplication. This illustration doesn't do it justice completely because the points are supposed to be on top of each other, but otherwise you wouldn't see it. The point is that you just duplicate points, and then you give it to your algorithm as is. But it's really important to do your train test split before. Because if you first do super sampling and then you split your data set into train and test, you'll have probably duplicated samples in both things, which will obviously give you wrong idea of your numbers. And there are also other more involved and more intelligent ways of doing the same thing. You could try to supersample using some kind of interpolation. If you know, you can assume something about the space of the things that you're measuring, your samples. And you can do clustering if you think there are clusters in your data, and then you can subsample, just, for example, taking the cluster centers to have a representative sample of your data, and so on and so on. OK, so we're just doing subsampling. It works well enough for now, and we put it in the random forest as a binary classification task. There isn't really much to be said about that. It's pretty straightforward. The only remaining question is how you choose your parameters, so like the number of trees, the depth, the minimum samples per leaf node, and so on. So for now, I just have a simple random search through some predefined space. But again, if you have used something like hyperopt or AutoML, which are things to find sort of an optimal set of parameters, I would love to hear about that, and I would love to try them out. The final thing about the model is that instead of getting just simple classification, we actually just get the probability, because that allows us to a little bit more flexibility. We can modify the threshold at which we think we classify something as good work. So the final ingredient is how to put this in production. That was me a while ago. I did some experiments in Jupyter, and I thought, OK, I'm done, right? I get good enough scores. And then I was asked, OK, so now implement it. And I didn't quite know how to do that. So basically what we need is some way of, because we're a web app, some way of exposing the predictions of the model through HTTP. So that's the basic idea. We have our main app, which is unfortunately written in Ruby, but don't blame me for that. Obviously, I didn't want to write, port parts of scikit-learn to Ruby. That would not be fun. So it's a separate service that just communicates over HTTP. Obviously, the application has a database that it needs to talk to and get information from. And this picture is enough for day-to-day operation. Once you have trained model, you get the data from the database. The main app requests, like, OK, tell me, is this job good or not, and gets the decision back. What's missing is training. How do you train the model? You could do that, but it's usually a bad idea. So if you read about how to structure microservices, the general recommendation is not to connect two separate apps to the same database, because then if you change the schema, you have to change two things and so on. It's generally a bad idea. So what we decided to do instead is something even worse. I'm just doing the training locally. But for now, it's kind of fine. We don't get we get lots of data, but it doesn't really change that much over time. So I can just do my training once a week or once a month, whenever I think we have more data to tell us something new. And it's good enough, so why not? Another requirement, it should be fast enough. And we also want to know which model is being used at which time, because we retrain every so often. We might change something, for example, change the feature vector, and then if something goes wrong, we would like to know what's going on and be able to debug. So let's build an API. Has anyone used Flask? Cool. So Flask is great. It makes it really easy to build an API. It's kind of like Django, but really stripped down and really easy to use. So to do the predictions, we load the trained model into memory, and then start accepting requests. So get a bunch of JSON data, convert it into whatever features you want, give it to the predictor, and return the response again as JSON. Pretty straightforward. The question is, how exactly do you serialize and load your model in a sane way? So everyone knows what this is? This is a pickle. So the answer to how to serialize stuff in Python is pickle. Except that's not always a good idea, because Well, there are a few reasons. First of all, there is this thing called joblib, which is actually shipped as part of scikit-learn, which is much more efficient at serializing NumPy arrays. So if you use joblib instead of pickle, your model will be smaller. But more importantly, there are many sort of more involved and more important reasons that using something like pickle, but also joblib, has the same problems. It's not always a great idea. And there was a great talk at PyCon 2014 explaining everything. The main problems are that by using something like this, you have lots of non-explicit assumptions about what you're doing. So for example, the pickled objects might not necessarily be compatible between different package versions. It's difficult to add versioning, and if you're unpickling things that you don't trust, you're going to have a really bad time because you're open to remote code execution. So don't do that if you cannot trust the files that you're deserializing. And all this is, by the way, mentioned in scikit-learn documentation, and it also tells you sort of the best practices of what to save with your model when you want to serialize it. So it's nice to have not only your model, but also your data together or somehow associated, so that when you so that you're able to retrain your model, recreate it, not only reinstantiate it. It's also nice to know the meaning of your feature vector, because as you're iterating, you might figure out that some features are not important, and then think of new ones that are actually really useful. And that might change the length of the feature vector, and that's sort of not as bad because it will give you an error pretty quickly. But if you somehow end up with two feature vectors of the same length, but different meaning, you get a prediction, but it's going to be meaningless. And performance scores are also good to know when you deserialize your object. You can check whether it's actually doing what it's supposed to be doing, what it did when you serialize it. So there's this simple package that I made that basically does all this for you. It's basically a wrapper. So you give it the model and all this metadata, and then you just save it. You get one zip file that you can upload to S3 or whatever, and then you can load it in again. And that's pretty simple. It's literally just like one class, but it gives you much more ammunition to fight bugs when something goes wrong. And specifically, we keep track of all these things. So we get the data, the names of the features, the hash of the Git code that generated the data, information about all the package versions, performance numbers, and when it was created. But it's not addressing all the limitations that pickling things generally has. So for example, we don't do anything to solve the security problems that I mentioned, so don't deserialize untrusted code. It also increases the size of your model. So if you're dealing with many terabytes of data, this is probably not a good approach. We might change it to just a reference or a link or whatever. But for now, it's an MVP. It solves our problem well. If you think it would be useful for you, please tell me, and I'm happy to expand it and make it useful for more people. And overall, there are also some limitations to the whole approach. So if you imagine a test case that Booking.com, for example, might want to write, they probably have several steps. So there's like, go to the homepage, log in, go to your profile, like upload a picture, whatever. It's a collection of activities, of steps. And our classifier at the moment only works step by step, so it gives you predictions yay or nay per step. But that's not exactly what we want. We probably want to tell, like, OK, this whole string of activities is good or not. And we use heuristic for that at the moment, but we can probably come up with something better. Finally, the data capture is not always reliable. It's funny how the most mundane feeling things sometimes give you the most trouble. But whenever your data is not what you expect, again, you cannot rely on it to give you a good prediction. And finally, there is lots of labeling effort involved. So we kind of grew it out for now. But if we ever decide to implement a new tracking way or basically add features that we didn't have previously, we need to start data labeling from scratch, and that will be massively painful. So we can probably use something like maybe not unsupervised learning, but semi-supervised learning or active learning, where the algorithm looks at the structure of the data and then asks the oracle, which is the user or the labeler, to label the things that will give it the most information. But again, this is future work. And thank you. I hope you got something interesting out of it, and I'm happy to take questions.
Maciej, thank you very much. I was happy there weren't too many Pokemon references as the title of your presentation suggested. Are there any questions? All the way in the back. Okay.
Thank you for your talk. I'm interested at the beginning when you mentioned all the information you are capturing from the users, the clicks, the speed. What are you using? Is that a library is it any open source library that you use to gather all the information?
It's JavaScript. So I mean, we always test web apps, so they always interact with the browser. So we just wrote our own piece of JavaScript that does it for us.
No.
Hi, thanks for the talk. You mentioned you use subsampling for model training. I was wondering whether you did some experiments with plotting the model accuracy against the degree of subsampling and how that
No,
that
I haven't,
like.
not yet. That's probably something I should do. In general, I wanted to do some kind of benchmark because it's a fun topic to explore, and there are many papers that give you all these cool subsampling or supersampling balancing techniques. I haven't done that yet.
Thank you.
More questions?
Here's one.
Maybe I missed it, but what kind of accuracy are you getting out of this with this model?
Right, so we get around 90%, which is okay, but the annoying thing is that I can't verify it, but I have a feeling that a lot of it is due to our data capturing problems. So for example, we don't always manage to capture everything that we need, and then we looked at sometimes we have a way of telling that the testers actually did something and their actions are not recorded, and that just blows up. Like, it obviously gives us the wrong prediction. But when humans label it, they label the right thing. And these are the things that are pretty dumb classifier cannot see.
Cool, thanks.
More questions? You're doing this on purpose, right? Make me run.
Would it make more sense to go into a trust model? Like, you can give them tests without them knowing, right?
Mm-hmm.
You know, at periodic intervals, you keep giving them, and so that their trust is retained.
Sure.
And you know, you lower and raise, and it's just a number that you multiply their results with.
Sure. So I'm sorry if I wasn't clear. This is sort of one tool that we have. We also do that. So we have sort of honeypots, and we have reputations, and we have we talk to the testers and make sure that they're happy. So we had like a pet name for this project, which was Robocop, because it's like a robot that catches people. But I think this is slightly limited way of thinking about it. So I don't want to give you the impression that this is the only thing we do. We actually want to encourage people to make it worth their time to do the right thing.
Anyone else? Question?
This is quite interesting, actually. So, as a website user using it a lot, I think you can use this methodology to measure happiness of the website users, not only testers. It could be a good idea. Have you thought about it?
No, not yet. How would you go about it? Would you measure if they interact more, that means they're happy?
Interact more, maybe staying on the website, but the lazy users, in your case, would be analogous with the unhappy users, maybe. Because they won't.
The one thing that I can see being tricky about it is that our testers know what they're getting into. They know they're working for us, and they know they're being tracked. I would have sort of problems putting this tracking on everyone who visits our website, because it might capture things that people don't want to be captured. And then if you try to measure happiness of people who work for you, they might not always tell you the right, the
It's
truth.
worth looking at it.
Yeah,
I would look at
sure, it is. It is.
Any more questions? Okay. Guess not.
Thank you so
Maciej,
much.
Thanks a lot. Give Maciej a hand.